Okay. So what are 17th group elements? Halogens. So what are the halogens we have? Astatin. Okay, fluorine, chlorine, bromine, iodine, astatin. Okay, all these are non-metals. What I am saying, all these are non-metals. But if you observe the physical states, what I am saying, observe the physical state. Fluorine is there now. Fluorine, chlorine are gaseous. What I am saying, fluorine, chlorine are gaseous. Then next, bromine is a liquid. What I am saying, bromine is a liquid. And iodine and astatin are the solid forms. Okay, so this is a radioactive one. So once again, first two, next one, next two, remember like this, and they will make a question like this. In the P block elements, a group with all physical state or with all three physical states, 17th group, because this group only we have seen something like this, nowhere we have studied right now. Okay, and the next thing is fluorine is there now. It's an yellow color gas. Which color gas? Yellow color gas. Chlorine, green color gas. Which one? Green color. Next, bromine is a brown liquid. Okay, fuming liquid. Okay, this one violet color solid. Which one? Iodine. What is the color of iodine? Violet color. Remember these things. Okay, the next, why we are calling it as halogens? What do we mean by halogens? Salt forming compounds. See, like NaCl, sea salts, now these all things. Okay, so that's why we are calling them as halogens. What is the general electronic configuration? NS2 NP5. Okay, next. So all these occurs as sea salts, therefore we are calling them as halogens. Next, all these elements are in diatomic form. Diatomic form means like if X is an halogen, it won't exist like this. It will be like X2. So what is the atomicity? 2. So these are diatomic, atomicity is 2. Next, what happens to their atomic radius, ionic atomic volume, density, electropositivity? Down the group increases like this. Okay, clear everyone up to here? So very easy, simple, it will be done in within some 10-15 minutes, just follow here. Next. Ionic radius down the group, ionization energy, ionization energy down the group decreases. Electronegativity, electron affinity order again important. So which is most electron affinity element here in the complete periodic table? It is fluorine only. So fluorine, chlorine, next fluorine, bromine, iodine, like this. Next, what is the common oxidation states of these elements? -1. Okay, fluorine never exists with a positive oxidation state. Which one? Fluorine, because it is the highest electronegative now. So always either with a -1 charge, or when it combines with itself, oxidation state will be 0. And what I am saying, fluorine never be with a positive oxidation state. Okay, fluorine never show positive oxidation state. Remaining elements like chlorine, bromine, iodine can show like +1, +3, +5, +7. So maximum, what is the oxidation state possible? +7. Okay, the best example here is IF7. Okay, so now what is the oxidation state of iodine here? +7. Okay, next. if you observe, the next thing here we have is solubility. Fluorine, chlorine, bromine, if you take, fluorine readily soluble in water, whereas chlorine, bromine sparingly soluble, iodine insoluble. It means solubility down the group decreases. Okay, next. Bond dissociation energy. What I am saying, next one is bond dissociation energy of these halogens. Highest for which one? Chlorine. The next for bromine. Next for fluorine. So why the order is changing like this means, see, fluorine, fluorine atoms, both of them are small atoms now. So small atoms with lone pair electrons. How many lone pair electrons? 3 lone pair electrons on each of this atom. There will be repulsions between the lone pair of this fluorine atom and this fluorine atom. So due to that repulsions, what happens? This bond gets weakens. Weakens means easily breaks. So that's why bond dissociation energy of fluorine is less compared with the chlorine and bromine. So what is the overall order? Highest chlorine, next bromine, next fluorine, iodine. Clear everyone? Yeah. Next thing is, you know, this which is a strong oxidizing agent we have seen that in that electrochemical series, if you remember, fluorine. Okay, so oxidation, like strongest oxidizing agent is fluorine. So down the group that that nature will be getting. So which is strong oxidizing agent? Fluorine. Right. Shit. Next. Okay. So which is strongest oxidizing agent we have studied now? Fluorine. So it means fluorine can oxidizes other ions and reduces itself. See, strongest oxidizing agent means fluorine wanted to stay in which form? F2 form or F minus form? F minus form. So fluorine will undergo reduction, oxidizes others. That's why we are saying F2 as a strong oxidizing agent. Next, see, F2 can oxidizes chloride ion, bromide ion, iodide ion. Okay. Now chlorine can oxidizes bromide ion, iodide ion, but not fluoride ion. Is this clear? Okay. Now tell me for bromine story. It can oxidizes iodide ions, but not fluoride ions. Is this clear? So this is based on what? Their oxidizing nature. So which is strongest oxidizing agent? Fluorine. Next, chlorine. Next, like that. Finally, iodine. Okay. So these two statements you write. Even we discussed this in the electrochemistry part also, if you remember. Okay. Then next, reactivity. So which is more reactive? Fluorine. Next, chlorine. So down the group reactivity decreases. Okay. Next one, reaction towards hydrogen. What is the next topic? Reaction towards hydrogen. So when halogens react with hydrogens, forms halogen acids. What they forms? Halogen acid. What do we mean by halogen acid? Like HF, HCl, HBr, HI. So even we discussed about this acidic nature. What happens to acidic nature, which is strong acid here out of all these things? Down the group, what I told you? Acidic nature increases. So strong acid is HI. Why? Because of this weaker bond overlapping, it will easily gives H plus ion. That's why HI is stronger. The next HBr, HCl, least is HF. Okay, HF is a weak acid. Remember this. Okay, so this is what bond dissociation energy order. If they ask, it should be like this: low bond dissociation energy, more acidic. So acidic nature will be like this. Okay, you can write these two things. Done. Okay, let's move forward. These reactions are important. Just look at here. Reactions with bases like alkalis. Fluorine, upon treating with cold dilute NaOH, reaction will be like this: F2 plus 2 NaOH. What is the condition I am taking? Cold line dilute. The product formed is like NaF. It means F minus is formed. Along with that, OF2 is formed. What is the product formed? OF2. Okay. If I consider this as a hot concentrated NaOH, a concentrated base, same NaF is fine here, but instead of forming OF2, the product formed will be O2. Okay. So this is a scenario in a case of fluorine only. For what it is? Only fluorine. Now if I take any other halogens, like I can take chlorine, I can take bromine, or I can take iodine. So in this case, if I use dilute NaOH, dilute base, the reaction will be like this. Cl2 is there now, so converts from Cl2 to OCl minus, like NaOCl minus, like this, NaOCl. Okay, and one more is chloride ion. So now what are the oxidation states formed? 0 is converting to -1, and here it will be +1. What are the two oxidation states formed? -1, +1. In which case it is cold dilute. Okay, if I say concentrated or hot concentrated NaOH, the product formed will be same like NaCl, here also NaCl, that is fine. But along with that, chlorate ion is formed like ClO3 minus. Here instead of writing minus, I am using here Na plus. So overall it is sodium chlorate. Now the oxidation state here is +5. What are the two types of products formed? Tell me once. Chlorine with dilute NaOH gives you chloride ion like NaCl plus NaOCl with what is the oxidation state of chlorine? +1, -1, +1. If it is hot concentrated NaOH, NaCl, that is chloride ion, but along with that chlorate ion, sodium chlorate with +5 oxidation state. Remember, this is a very important reaction, and we have a question on this in the previous exams also. Okay, especially in EAPCET. Next one, remember this one also. Fluorine, the reaction is different from remaining elements, remaining halogens. Why? Because fluorine is a strong oxidizing agent now, that's why. So can I say this reaction as a disproportionation reaction? These two reactions. Why? Because 0 converting into -1, +1. Disproportionation. 0 converting into -1, +5. Both of these are disproportionation. Remember. Okay. Done up to here? Do it fast. If you finish it fast, we have some time for solving questions. That's why. Next one, if you see this, chlorine with calcium hydroxide forms CaOCl2. So what is the name of this compound I told you? If you remember, told you about bleaching powder. So what is that? CaOCl2. Okay, this is like this, CaOCl2. So CaOCl2 means, how I told you what are the oxidation states for chlorine. Here it will be in two oxidation states I told you. One chlorine with -1 charge, another chlorine with +1 charge. Okay, and oxygen will be with -2 charge. Remember, this is the oxidation states of chlorine in bleaching powder. So write this as CaOCl2. Done? Okay, next, chlorine preparation. Have you studied this chlorine preparation, decons method? Okay, so what is the catalyst used there? CuCl2. Just write 4HCl with oxidation, the presence of CuCl2 catalyst produces chlorine gas. Okay, so what is the method here we are using? Decons method. So what is the catalyst used in decons method? CuCl2. Product formed is chlorine gas. Okay, right. What are the halogens in the gaseous state? Fluorine and chlorine. Liquid state? Bromine. Okay, next. So non-metals forms which type of oxides? Acidic oxides. Acidic oxides upon hydrolysis gives you oxoacids. Morning class we discussed oxoacid. So here halogens are non-metals now. So they will form acidic oxides first. Upon hydrolysis gives you oxoacids, like oxoacids of halogens here. Okay, it can be of this many types. It can be of like HOX type or HXO2 type, HXO3 type, HXO4 type. So examples here are, in the place of X I am placing chlorine, HOCl you can say. Okay, hypochlorous acid. What is this? Hypochlorous acid. So here you can see HClO2. What is the oxidation state of chlorine in this case? Because oxygen is more electronegative now, so it should be +1. Here in this case it is +3. Here it is +1, +3, here +5, +7. 4 to the 8, -8, +1. It means +7 is for halogen. Like this. Okay. So now if I am saying same halogen is present in all the cases, like chlorine, 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 chlorine. So now how can you say which is more acidic here? Oxidation number. Which is greater oxidation number? So this will be more acidic. This is the acidic nature order. Okay, is this clear, this point? Okay. Now previously asked EAPCET question is like this. The basic nature order of even if we have solved this question in equilibrium chapter, if you remember. Anyways, I am going to create here. Just see, ClO2 minus, ClO3 minus, ClO4 minus. What I am asking? Basic nature order or increasing order of basic nature. Tell me. For these ions. Do you remember we used one statement? A strong acid, conjugate base will be weak. Like Brownstein acid base theory we discussed. A strong acid, conjugate base will be weak. Which is strong acid here? HClO4. So its conjugate base will be weak. So conjugate base, what is the conjugate base of it? After releasing H plus ion, the negative part will be there now. That is called its conjugate base. So this is weak base. Then next to this one, next to this one. So like this. Is this clear, everyone? Write this order. Beside that you can make a question question with answer. what is the final statement you are using there? A conjugate base of a strong acid is weak base particularly. Okay, so HClO3, if it is an acid, what is its conjugate base? ClO3 minus, acid conjugate base. Here is stability. All these oxo acids you are seeing now. So which is more stable, they will ask. See, for a particular halogen atom, higher the oxidation state, higher will be the stability. So see what I told you, just in the simple words, more number of oxygens, more stability. For a particular halogen atom, what I am saying, more the number of oxygens, more is the stability. Remember like that. Okay, next one, acidic nature also what I told you, more electronegativity. Here all halogens are, all of these are halogens are same, like chlorine only. Now what to check? Oxidation state. Higher the oxidation state, higher is acidic. Or you just remember more number of oxygens, more acidic. Like that also you can remember here. Okay, next when it comes to oxidizing power, what I am saying, oxidizing power, it will be reverse of the above order. Okay, HOCl like this, reverse of the above order, right. So stability, how you decide? More number of oxygens, more is the stability you can number. Next, acidic nature, more oxidation number, more acidic. Oxidizing character, reverse. Over. Next. Okay. So now we have seen halogen atoms as same, like HOCl, like HClO3, like that. Now what I am doing here, changing the halogens for different halogens with the same. Okay, wait. For different halogens with the same oxidation state. What I am saying, with different, for different halogens with the same oxidation state. Now what I am saying, more electronegative atom, more is a acidic nature. Let's see this. HClO3, HBrO3. Which is more acidic I am saying? +5, +5. Different halogens with the same oxidation states. Now what, how can you decide? Like this. Okay, next. And more electronegative atom, more acidic nature. In the same way, more electronegative atom, more stability. So stability also follows the same one. Okay, and more electronegative atom, more is the oxidation. Like this, everything is like this. Write this statement. Okay. Over. Next one, interhalogen compounds. Interhalogen compounds means like if X is one halogen, X dash is another halogen. So the compound formed from these two are considered as interhalogen compounds. For example, if X is chlorine, X dash should be like fluorine. Okay, like it can be ClF, ClF3, like this. What we can say, these compounds as example of interhalogen compounds. So X one halogen, X dash another halogen. Okay, so like this, when you are making interhalogen compounds, you need to keep one thing in the mind. The central atom should be less electronegative than the surrounding atom. What I am saying, central atom should be less electronegative than surrounding atom. For example, if Br is central atom, what could be the surrounding atom here I should take? Fluorine or chlorine. You should not take iodine. Okay, so it is something like F3 or Br, F5, like this you can consider. Okay, so like that I have given some examples over here. So it can be ClF, BrF, ClF3, BrF3, BrF5, like this they will give. And you know hybridization concept now. Can you tell me the shapes of these molecules quickly? Like what is the central atom here we have? Halogen atom. Halogen atom means always 7 group number. Okay, so 7 plus how many surrounding atoms? Halogens means mono, like what I can say? Valence is 1 na? Okay, so what you can say, how many halogens are there? Monovalent only na? So take it as 1 by 2. So it can be now 4. 4 means sp3. So what is the hybridization of chlorine here? Here bromine. Bromine. Same 4 number means sp3. So sp3 means how it should be? Chlorine. Tetrahedral fashion it should be there. But how many surrounding atoms are there? 1 surrounding atom I am placing. It means remaining positions are occupied by lone pairs like this. So lone pairs you just keep it on the chlorine like this. So fluorine will be here. Okay, like this you can arrange. Is this clear everyone? Okay, can you answer me for this type of model? 7 plus 3 by 2, 5 sp3. But what is the shape or structure? sp3d means what, ma'am? Trigonal bipyramidal. But how many surrounding atoms should be there for that? sp3d means 5. But how many atoms we have here? It means remaining 2 positions are occupied by where that lone pairs should be placed? Equatorial. See, chlorine, like these positions are there now. So what is the angle here? 90. What about this angle? 120. Okay, where do we have maximum separation? 90 or 120? So with maximum separation you need to place lone pairs. We already discussed this story. Okay, so lone pairs you first place in the equatorial. Remaining positions occupied by surrounding atoms. How many surrounding atoms? So place 1, 2, 3. So how the shapes looking like? T shape. So if the interhalogen compound is like X3 type, what is the shape of that molecule? T shape with the 2 lone pairs. Next, BRF5, this model you tell me. 7 plus 5 by 2. 6, it means sp3d2 means octahedral. Octahedral means there should be 4 ligands, I mean 4 surrounding atoms. But how many we have? It means one position is occupied by lone pair. Okay, so now the remaining position looks like, remaining structure looks like what? Octahedral, you know now how it will be. If this is a central atom, like first a square, above one line, below one line. But one of this line is now occupied by what? Lone pairs. So just remove this lone pairs. How it is? Like a square, square, one pyramid only now. So square, pyramidal. So this model compounds will be having now what? Square, pyramidal. Next you tell me for this one. What? What is the hybridization you will get? sp3d3. So with sp3d3, how many surrounding atoms will get this? 7. All 7 atoms are there now. So it will be like pentagonal bipyramidal. What is that? Bipyramidal. Because how many atoms are there, ma? 7. See, if there are 5, we have trigonal bipyramidal. If there are 7, pentagonal, it means you draw a pentagon like this first. This is a central atom. Put 5 fluorines like this. Still how many fluorines are there? Above 1, below 1. So pentagon, both above one pyramid, below one pyramid. So pentagonal bipyramidal. That's it. So now how can you prepare this? So the preparation will be like this. Chlorine, fluorine. Okay. So their volume ratios should be like this. 1:1. So that you are going to get what? ClF as a product. So see, chlorine, fluorine 1:1 ratio if you take, what will be the product from? ClF. Okay. If you are taking bromine, fluorine like this, you will get 2BrF3. Next, iodine, fluorine as a 1:5 ratio. See, 5 we are taking now, BrF5. See here, 3 you are taking now. Okay. Next, in order to prepare IF7, first you prepare IF5. Then treat this IF5 with the fluorine. So 5 plus 2. So IF7 like this you will get. Okay. So all these compounds are diamagnetic. Next, interhalogen compounds are more reactive than respect to halogens. For example, I am making a compound by treating chlorine, fluorine. I am making compound by treating fluorine and chlorine. Let us say the product formed is something like ClF3. So tell me who is more reactive, whether these halogens or this compound. This compound is more reactive. Interhalogen compounds are more reactive than respect to halogens. Okay, that's it. Okay. So now reactivity order, particularly if they mention, this will be the reactivity order for the interhalogen compounds. Some compounds only I have mentioned, just take the list of this. What is this A2X2 means? This is one halogen, another halogen. Respect to interhalogen compound. Which is more reactive I am saying? Interhalogen is more than respect to atoms. Okay, next. Okay. See, we know alkenes are unsaturated compounds now. Alkanes are also unsaturated compounds. So I am giving you one random example of unsaturated compound. I am asking how many degrees of unsaturation it has or how many pi bonds it has. We can able to identify using VG's reagent. What is it? It is nothing but ICL. So what is the use of ICL? We can able to identify, use it for calculation of number of unsaturated bonds in a long chain fatty acid. For example, there is one pi bond, we require one ICL because one I goes here, one chlorine comes here, like that. The number of iodines that is used during the process gives you number of unsaturated bonds. Okay, so this is also considered as iodine number or VG's reagent. What is that? ICL. Okay, write in the short form fast. Okay, next. Only here, up to here you write. Next thing, you know, halogens. Halogens means definitely like it should be like X minus, like fluoride minus, bromide minus, like that, no? So there are some compounds, we can call them as pseudo halogens. What we can say? Pseudo halogens or pseudo halides here. Pseudo halides. In pseudo halides, there is no halogen atom, but they behaves like a halogen. What I am saying, what do we mean by pseudo halides? There is no halogen, but that compound behaves like a halogen. See, Cn minus is there now. So do you see any halogen atom here? But it shows some characteristics similar to halide ions. Okay. Now, how can you identify whether a given compound is pseudo halide or not? One thing is common. All pseudo halides contains at least one nitrogen atom. What I am saying? All pseudo halides contains at least one nitrogen atom. Like see cyanide ion, like thiocyanide ion here, cyanate ion here, azide ion here. What you are saying, all in these compounds, one nitrogen atom at least. So we can consider them as pseudo halides. So why we are calling them as pseudo halides means, for example, HF, HCl, these are acids. Right now, similar to that, HCN is also acid. Okay, it means whatever the nature this HF is showing, similar kind of nature is shown by HCl. So that's why we are calling this Cn minus as a pseudo halide. Okay. Now we know halides or halogens exist in diatomic form like this. Similar to that, these pseudo halides also exist in diatomic form. I mean like dimeric form, like Cn2 minus, like Cn twice, SCN twice, like that. Okay. Done. Completed? Now I just want to ask you, what is the oxidation state of nitrogen here? అంటే what is the charge on 3 nitrogens? Otherwise you take hydrogen will be plus 1 charge, then complete this N3 will be minus 1 charge. So 3 nitrogens, so 3x equals to minus 1. Then x will be, so 1 nitrogen atom, what is the charge? So this is how you calculate oxidation states. Okay. Next. Up to here 17th group is done. Next 18th group. What are the elements we have in 18th group? Tell me. Helium, neon, argon, krypton, Og. What is the last element? Og. Okay, what is atomic number? 2, 10, 18, 36, 54, 86, 118. What is the general electronic configuration for all this? Ns2, Np6, except helium, because atomic number 2 now, so it is 1s2. For this one, helium, after that 2s2, 2p6. For this element, neon, 3s2, 3p6. So 10 plus 6, 18. Next, this one, argon 18 over, see 3 is over now, so 4s2, 4p6, just count now, argon 18, 20, 26 only. We are getting 26 only, it means here 3d 10. Next, this one you tell me, krypton 36, next 5s2, 5p6, again check now. Here 4d 10. For this one, xenon 5d 10, 6s2, 6p6, inside if you count 60, 72, inside 4f14. Okay, whenever you are writing 5d, before that 5d what should come? 4f. Or whenever you are writing 6s, like if there is ns, there should be n minus 1d and n minus 2f. Here you can, 6 means n minus 1 5, 6 means n minus 2, 6 minus 2 4. Okay. Next, this one you tell me, radon 86, 5f 14, 6d 10, 7s2, 7p 6. If you remember, for no group I have written all the electronic configuration because I know you can able to write. Just for cross verification I have given only for 18th group here. Okay, if you know you can directly write. Okay, anyways, from xenon, see all of these are gases only. First of all, what I am saying, all of these are gases only. From helium to xenon, from where to where I am saying, helium to xenon. Who identified them? Ramsay. Who identified? Ramsay. So they got Nobel Prize for identifying this. Okay. So all of these are monoatomic. What I am saying, all of these are monoatomic. Like fluorines, halogens, how what we discussed, they are diatomic we discussed. But like this one, inert gases, noble gases are monoatomic, like they exist like independently. Next thing is, previously they are considered to be inert gases. How they considered to be? Inert gases. But later they got to know xenon is having some reactivity. Which element is having reactivity? Xenon. Xenon, radon are showing some reactivity. Therefore, they have changed the name as noble gases. First, what they called? Now what they are calling? Also 18th group or also 0th group. All these are same. Okay, remember. Now what is the valency of these elements? 0, because they won't show reactions now. So 0. Next. We know down the group what happens to the size? Increases. Okay. Next one here you can see, moving down the group, van der Waals radius increases. Melting point, boiling point also increases. Because sizes increasing now. If two big sizes are there, means between them van der Waals forces will be more. So that's why more boiling point and melting point as we go down the group. Okay, write this order. Directly you can write. Okay, 2 slides last. Okay. So these reactions are important again. Okay, write what you want to write. Done? Next, xenon fluorine reaction. These compounds are important. Xenon fluorine reaction. See here, mole ratio is 1:1 you are seeing. But how you should take the volume ratio? 2:1. So xenon has 2 volumes and fluorine has 1 volume. The product will be these things. What are the products? XeF2, XeF2, XeF2. So what you are taking the extra quantity here? Xenon. So if you take xenon as extra quantity, products will be XeF2 type. Okay, it can be in the sunlight, or it can be in the nickel tube, or it can be the electric arc at the room temperature. RT means room temperature. Okay, so now if I take 1:5 ratio, what I am taking? 1:5 volume ratio. The product will be formed like this: XeF4. What is this? XeF4. What is the ratio we have taken? Volume ratio is 1:5. So here this can be also in nickel tube or in presence of sunlight. Product formed will be XeF. Next, if I take 1:20 ratio as a volume, what I am taking? 1:20. The product formed will be XeF6. So for XeF2 form, XeF2. For this, what is the volume ratio I should take? 2:1. Next, for XeF4, 1:5. Next, XeF6, 1:20. Okay. So all these are what? Colorless solids, these compounds that form. Okay. Now I will ask you a simple question. Tell me, what is the hybridization and shape of this XeF6? sp3 d 8 na 8 plus 6 14/2 7 means 4 5 6 7. Okay, sp3d3 means what is the hybrid? Geometry should be pentagonal bipyramidal. Pentagonal bipyramidal, if all positions are occupied, we should say pentagonal bipyramidal. But in order to occupy all 7 positions, how many groups should be there? 7. But how many we have? It means another position is occupied by lone pair. So in pentagonal bipyramidal, if you have one lone pair, you should call it as distorted octahedral. What you should call? Distorted octahedral. Remember this, it's an important question. Okay. నెక్స్ట్ అయిపోయిందా? ఏంటమ్మా? ఎలక్ట్రిక్ ఆర్క్. Done? Yes. One last slide. Okay. So now what are the compounds we have seen? XeF2, XeF4, XeF6. So now how do they undergo reactions? See what I am saying? Hydrolysis of XeF2. So hydrolysis of XeF2 provides xenon plus 4HF and oxygen is released. So what I am saying, xenon compounds is soluble in H2O. Once again, xenon compounds are soluble in H2O and much more soluble in HF. So solubility of xenon compounds is more in HF. Remember this. Once again we will discuss. Xenon difluoride upon hydrolysis, xenon plus HF plus O2. Okay. So this process, this reaction process is slow. What I am saying, this process is slow. But if the same reaction if I perform in the basic medium, hydrolysis is rapid in the alkali or basic medium. So the same reaction I am doing in the basic medium, so you will get a xenon with O2 and NaF. Okay, so you can say this is a fast reaction. Okay, next. So here you can see xenon difluoride is there now. So upon treating with PF5, so these PF5s are fluoride acceptors. What I am saying, fluoride acceptors. So if it is accepting one fluoride, what happens to this compound, tell me? Take one fluoride from here to here, it becomes PF6 minus, this becomes, so like this you can write. So what we can call PF5 as a fluoride acceptor. So not only PF5, they may also give you SBF5 also. What is the compound they may give? SBF5 also. Next, see, xenon tetrafluoride upon hydrolysis producing xenon plus XeO3. What is the compound produced? XeO3. Now what is the geometry of this XeO3, can you say? What is the shape of this XeO3? Xenon, which group? 18th group. So 8 valence electrons, 8 by 4, 8 by 2, 4. So 4 means sp3 hybridization. But shape becomes, how many bond pairs are there? 3. So sp3 with 3 bond pairs, 1 lone pair. What you should say? sp3 with 3 bond pairs, 1 lone pair. What happens to the structure? Trigonal pyramidal. What it becomes? Like NH3 structure is there now, like that, pyramidal. Okay, next, XeF6 with 1 water molecule. How many oxygens are there in this? Give that oxygen to here. When you are giving 1 oxygen, we know oxygen is divalent and fluorines are monovalent. For 1 oxygen you remove 2 fluorines. What happens? XeO4. I am giving here 2 oxygens. For 1 oxygen, 2 fluorines. For 2 oxygens, so it means it becomes XeO F2. XeO2 F2, remember. Next, I am giving 3 oxygens. For 1 oxygen, 2 fluorines you are removing. For 3 oxygens, all 6 remove. So it becomes XeO3. Okay, so this XeO3 is there now, it's an explosive solid. What is that? It's an explosive solid, remember this. Done. So do you have any questions to solve? Time అయిపోయినట్టుంది కదా.